students, a very good morning to all of you. This is Dinesh Mehbubani in the video lecture series of Numerical Methods in Chemical Engineering. See, in this subject, we have almost completed all the chapters except one chapter. The last chapter is remaining. The name of the chapter is Numerical Solution of Ordinary Differential Equation. Okay, first of all, you should know what is the meaning of ordinary differential equation. See, basically differential equation are of two types, ordinary differential equation and partial differential equation. These things you have already studied in the previous semester. What is ordinary differential equation and how you can find the order of the differential equation? All these things you might be knowing, okay? So what is the basic difference between ordinary and partial? If the differential equation consists of dy by dx, d square y by dx square, that means it consists of full derivative, total derivative, then it is known as ordinary differential equation. And if the differential equation consists of del, okay, del square y by del x square, del y by del x, then that type of differential equation is known as partial differential equation. Okay, in our syllabus, the partial differential equations are not there. We have to only study the solution of the ordinary differential equation. Okay, so let us start the last chapter of our syllabus. Okay, now how to solve the first order differential equations? First of all, you should know what is the meaning of first order differential equation. See, which equation are known as first order differential equation? Okay, if the equation consists of x, y and y dash, okay, here y is a function of x, okay, y is dependent variable, x is independent variable, so the differential equation that consists of two variables, out of these two variables, x is independent variable, y is dependent variable and y dash is the derivative. See, it is the derivative of first order, so I have taken here y dash. Here y dash is also written as dy by dx. Okay, so this type of form of the equation is the form of first order differential equation. Let me write one example. Dy by dx plus y sin x is equal to 0. Y dash plus e raised to y into x is equal to 0. So these are the examples of first order differential equation because only dy by dx term is there, only y dash is there. Okay, so we have to solve these type of differential equations in this chapter. Okay, we are not going to find the solution of the higher order differential equation, but we are going to solve the first order differential equation. See, in maths 1 and 2, see, you have already studied that how to solve these type of equations. See, if you remember, there are basically three types of differential equation: linear, exact and non-exact. See, these are the conventional methods. Conventional method in the sense, first of all, you have to identify that the given differential equation is linear, then you have to apply the steps of the linear equation. Similarly, if the equation is in the exact form, then you have to first of all check it is exact or not, and if it exact, then the solution of the exact differential equation is to be used, and for non-exact you have to use 4 different cases. So in this way, if any first order differential equation is there, so you can solve like this. You have to check whether it is linear, exact, non-exact. You have to follow a number of steps, okay, a number of many things you have to remember. You have to remember many things, but in this chapter we are going to study about the numerical solution of differential equations. Numerical solution means what? That we have to find the solution in the approximate form. Approximate form in the sense we have to find the iterations, we have to find the approximations. Okay, so to find the approximations, we will require, we will be having three different methods: Taylor's, Euler's, and Runge-Kut. So in this chapter, we are going to study Taylor series method, Euler's method, and Runge-Kut method. Okay, okay, fine. What will be given? See what will be given in this. So we can say dy by dx is equal to f of x comma y will be given, and the numericals in this chapter will be IVP. Okay, IVPs will be given. Now what is the meaning of IVP? IVP is the initial value problem. So initial value problem will be given, dy by dx is equal to f of x will be given. Okay, and the initial values will be given. See, the value inside the bracket is the value of x0, and the value outside will be the value of y0. And if they are asking that find the value of y of x, okay, find the value of y of x, then we have to take the step size. See, if you remember, this is the value of x0. In interpolation, what we were doing? We were taking the differences of h in the values of x, where h is known as the step size. Okay, here h will be known as the step size. Okay, so we have to first of all see what will be given. X0, y0 will be given, and on the basis of x0, y0 we have to find x1, y1. Okay, so by taking difference of h, x1 can be found. X1 is equal to x0 plus h, and if I want to find the value of y, then I have to apply the different methods. So this equation, these type of methods are used to find the various values of y for different values of x. For example, as I told you, what will be given? Y0 and x0 will be given. So if I want to find y1, then what is required? X1 is required. If I want to find y2, then x2 is required. Okay, so in this way we can find the values of y for different values of x with the help of the different methods used in this chapter. Okay, fine. So let us start from the first method, that is Taylor series method. Fine. See, in this chapter there is no need to remember the theory. You have to only remember the formulas, and we will solve the numericals on the basis of that formulas. There is no need to remember the theoretical portion, right? See, as I told you, what will be given? Given that dy by dx is equal to f of x comma y, IVP will be given, so y of x0 is equal to y0 is given. And if I want to find the value of y of x or y of x plus h, so by applying the Taylor series, I can write it like this: y of x plus h into y dash of x. You have to directly remember the formula, plus h square by 2 factorial y double dash of x plus h cube by 3 factorial y triple dash of x plus, and so on, h raised to n upon n factorial into y raised to n of x. So in this way you can find the solution with the help of Taylor series. This is a general formula. See what is given, x0 and y0 will be given. So if I want to find y1, okay, y1, what is y1? y1 is equal to y of x1. And what is our x1? See, x1 can be written as x0 plus h. So if I want to find the value from this formula, okay, then what I have to replace, see, instead of x I have to take x0 because I want to find y of x1. Okay, y of x1, you can compare these. X1 is equal to x0 plus h I have to take here. So what will be my x? So my x will be x0. So this can be written as y of x0. See, this is the formula to find y1. Okay, and what is required to find y1? X0 and y0 are required to find y1. Okay, so y dash of x0, h square by 2 factorial, y0 double dash x. Okay, I can write like this: y double dash of x0 plus h cube by 3 factorial, y triple dash x0, and so on. Okay, till h raised to n upon n factorial and the nth power of x0. So this is the formula for finding the first approximation y1. So if I want to find y2, then what I have to do? For y2, we have to replace x0 by x1. Okay, so x0 will be replaced by x1. So you can write this formula. See, these type of formulas are known as step-by-step methods. These type of methods are known as step-by-step methods. Okay, it is a step-by-step method. Remember why it is known as step-by-step method? Because to find y1, what is required? x0, y0 is required. To find y2, what is required? x1, y1. So we have to solve this step by step. First of all, we will find y1, then we will find y2, then we will find y3. So if I want to find y3 directly from y1, then it is not possible. Okay, so to find y3, we have to go in a sequence. We have to follow the steps. Okay, first of all, find y1, then y2, then y3. So these type of methods are known as step-by-step methods. Fine. So all the methods in this chapter that we are going to study are step-by-step methods. Taylor series method, Euler's method, and Runge-Kut methods. Fine. Okay. Okay, let us take a numerical on the basis of Taylor series method. Let me write the numerical. Using Taylor series method, find y of point 1 up to 4 decimal places, given that y dash is equal to x square plus y square and y of 0 is equal to 1. Okay, see, this is the given data and we have to find the solution of this. First of all, you have to write that what is given. Okay, what is given here? See, f of x comma y, or we can say y dash is given, that is x square plus y square. The value of x0 is given as 0 and the value of y0 is 1. Okay, and we have to find the value of y of point 1. How I can find the value of y of point 1? See, y of point 1 means what? I have to take x is equal to point 1. So if I want x is equal to point 1, then I have to take h is equal to point 1 because x1 is equal to x0 plus h. So my x1 will be point 1, h will be point 1. We have to assume the value of h, okay? And we have to find the value of y1. Okay, see, if we remember using Taylor series method, y1 can be written as y0 plus h y0 dash plus h square by 2 factorial y0 double dash h cube by 3 factorial y0 triple dash plus h raised to 4 by 4 factorial and so on. Okay, See, there is no need to find further because we will get the approximate solution. So we have to use this sign, approximate. Okay. So first of all, we have to find all these values. Okay, y0 is already given. Y0 is 1. Okay. H is also given 0.1. Y0 dash, Y0 double dash. These values we have to find. So how we can find these values? We have to take the derivatives. Okay. You note it down. Let us take the derivatives and then we will place the values. Okay, so we have to place the values of the derivatives in this formula, then you will get the answer. Okay, see, let me find the general derivatives in the sense y dash is given x square plus y square. So what will be my y double dash? The derivative of x square is 2x plus derivative of y square 2y into y dash. Why y dash? Because if you remember the explicit function, y is a function of x, so we have to take here y dash. Okay, y triple dash, derivative of 2x with respect to x is 2 plus 2y as it is, derivative of y dash is y double dash, multiplication rule you have to use. Okay, plus 2y dash as it is, and the derivative of y is y dash, so it can be written as 2 plus 2y dash 2y double dash plus 2y dash square. Okay, what will be the fourth derivative? See, fourth derivative, this term will be 0, then 2y double dash, so 2y as it is, y triple dash plus 2y double dash as it is, y double dash, 2y double dash into y dash. Okay, now here I have to use chain rule, so 4 into y dash into y double dash. So what will be my answer? 2y triple dash plus 6y dash y double dash. Okay, these are the general derivatives. Now what we have to find? We have to find y0 dash, y0 double dash, y0 triple dash, y0 fourth derivative. How we can find this? Say in place of x and y we have to place the value of x0 and y0. So this can be written as x0 square plus y0 square. Okay, y0 double dash can be written as 2x0 plus 2y0 into y0 dash, then 2 plus 2y0 into y0 double dash plus 2y0 dash square, and here I can write 2y0 y0 triple dash plus 6y0 dash into y0 double dash. If you will place all of these values, your answer will be y0 dash will be 1, this will be 2, then y0 triple dash will be 8. Okay, and y0 raised to 4 will be 28. So these are the values that we have to place in the Taylor series formula. And after placing all of these values, okay, after placing all of these values, you will get the final answer. Okay, so the final answer of this numerical will be y of 0.1 is equal to 1.1114. Up to 4 decimal places you have to find. So you have to fix the digits in the Kelsey as 4. Okay, so this was about the numerical of Taylor series. There are more numericals given in the question bank. You have to solve that numericals, and if you are having any doubt, then you can ask me. In the next lecture we will solve one more. We will study about one more method, that is Euler's method. Okay, till then have a good day. Bye bye.